Hello guys, so today we're going to be doing quadratic equations and linear equations, and we are going to be solving them with the process known as substitution. So here is an example of one of the systems of equation we want to solve. We have y equals 4x plus 5 and y equals 2x squared plus 3x plus 4, which is a quadratic part. And we're gonna try to find the x in this equation. We're gonna try to solve for x by using some inverse operation. We get y minus 5 divided by 4 is equal to x. And the reason we probably didn't do it for the quadratic and we did it for the linear equation was the linear equation is much easier to do. Okay, substituting. Now we're going to substitute this equation, which we found from the linear, into the quadratic equation, which is right here. And this is a very lengthy process. And you could see that there's a lot of fractions, there's a lot of, things going on here. So off of the slideshow, I didn't show it in the slideshow, I actually simplified this equation and made the first term, which is the 2x squared part, that would be y squared minus 10y plus 25 divided by 8. And the second term would be 3y divided by 4 minus 15 fourth, which is this part right here. And I didn't include the third term, which is just 4. It's a constant. And we're going to continue substituting. Now we got these, after we solved it and simplified it a little bit. And what we want to do here is we want to clear out all the fractions, which makes it easier for us to solve it. So we multiply everything by 8 because that's a common denominator. And we add like terms. And since we're going to be solving a quadratic equation, we want to make the right side equal to 0. So we subtract the 8y that's to the right. And we get left another quadratic equation. Y squared minus 12y plus 27 equals 0. And remember that we're solving for y, not for x. But we're going to use the same process. So you could either factor it or use a quadratic formula. Since this is a pretty easy quadratic equation to factor, we could just factor it like normal and put, negative 9 times negative 3 equals 27, and negative 9 plus negative 3 equals negative 12. So we will get the solutions y equals 9 and y equals 3, making the whole equation equal 0. But we could also use the quadratic formula, and we use the quadratic formula when you can't factor it out easily. So I wrote the quadratic formula here, but I actually simplified it a lot. So the square root of 36 is 144 minus 4 times 1 times 27, if you're wondering how I got 36. And then the 12 is negative 12, and then 2 is from the a. Then I separate this into two equations and solve from there. So 12 plus the square root of 36, which is 6. So 12 plus 6 is equal to 18 divided by 2 equals 9. So y equals 9. And 12 minus 6 is 6 divided by 2 is 3. So we got two solutions here. Now, solving for x. We have got our two y's for this quadratic. And now we're just going to input those two y's. We're going to start with, as I mentioned here, y equals 9. And we're going to inverse operations here. We're going to use inverse operations. And we see that x is equal to 1 when y is equal to 9. And we also set up another equation where the other y is equal to 3 because in a quadratic equation we have two solutions. So then we solve and we get x is equal to negative 1/2. And the reason why I highlighted these in green and blue is because I want to match up this x with this y. So we're going to have negative 1/2, 3, and 1, 9. So the solutions are 1, 9, and negative 1/2, 3.